fiber optic is a piece of glass that's a long thread that will carry light along its length. Now let's imagine that you take that fiber optic glass thread and you shrink it down until it's just a couple hundred nanometers across. And that's now, maybe a tenth the diameter of a human hair. Very tiny, but it will still transmit light along its length, and you can actually pattern those on a silicon chip. So the way you turn that into something that's going to work like a sensor is, it turns out that some of the light, I need a prop. I need a better prop. Let's say this is my piece of like fiber optic on a chip. It's actually called a waveguide, because what it's doing is it's guiding light down the length of this thing. Some of the light actually sort of leaks out as it's going along. And an analogy that I make is, if you take a paper towel tube and you hold it under a faucet and the water's running, as the water runs, obviously your hand's going to get wet because the water kind of soaks through the cardboard. But actually, the water going through that tube also feels some of the warmth of your hand. So out the other end, it'll be a little bit warmer and you can report on the warmth of your hand. We're doing the same thing with light, in that if something that's an antibody to SARS-CoV-2, the COVID-19 virus, sticks to that waveguide, the light that's coming out of the waveguide kind of feels that. And then if I have a reporter, basically a power meter out at the other end, I can actually pick that up, that something stuck to the waveguide, or lots of things have stuck to the waveguide. So, okay, great. Well, what's cool about that is we can make these things tiny. So here's one of our chips, which you may be able to see just that little speck in the middle.